Welcome you all to the video lecture of computer architecture. Here in this video lecture, we are going to discuss regarding to the session 5 topic addressing modes. So here this addressing modes is mainly mentioned regarding to the top how your processor access the memory and operands which with in order to explain the performance of the various operations such as add, move, like these operations we need to access in the processor. So with those operations has been successfully completed with respect to the top this addressing modes. So this addressing mode will perform helps to perform what the various operation in the processor. So according to this addressing modes, it has been classified into many different types, around I think so of 9 different types of addressing modes as we are going to discuss here. The first addressing mode is a immediate addressing mode. Here, this immediate addressing mode has been represented with respect to this hash symbol in an instruction. That is, for an example, here this instruction has been given. Here in this instruction is directly we can be able to say that it is a immediate addressing mode with the help of this hash symbol. So here this hash symbol says is that it is an immediate addressing mode type of an addressing mode. Here, this instruction, this hash symbol says is what? Actually, it is a value, which means that here this value will be get added to the content R3. So R3 will be get added with respect to this plus 200 and then places this result, which means that R6 plus 200 value has been placed in the register of R4. So from the instruction which is represented with the help of this hash symbols, it is going to be said as a immediate addressing mode. So the next addressing mode is a register addressing mode. Here this register addressing mode will help us, which means that this here the operand will be located in a CPU register. So instead rather than the top of main memory. So without accessing the main memory, here the CPU register has been utilized in order to mentioning, which means that locating this operand. So therefore the instruction which will be specified the register containing the operand directly, which means that the instruction has a register which is directly mentioned like this. Here in this instruction, the registers has been directly mentioned. So from this instruction, we are able to say that here the value in the register R2 will be get added with the register of R1. So here this register has been directly mentioned over this addressing mode. So the next addressing mode is the direct addressing mode. So from this instruction here we are able to see this instruction move R1 comma 1000. So here in this instruction the explicit thing has been mentioned here is the memory address. So from the instruction itself we can able to explicitly we can able to get what the memory address. Here this 1000 will says us to the top address, which means that explicit memory addresses of an operand. So move R1 comma 1000, here the 1000 is directly explicited the memory address for doing the instruction operation with to the top operand. So automatically the processing unit will be moved directly to where the specified memory location to in order to fetch the data content anything to the top values is from the register. So nothing we can able to say that simply we can say that move the value from memory address of 1000 to R1. So this is the direct addressing mode. The next addressing mode is indirect addressing mode. So here this indirect addressing mode can be effectively able to explain that here the operand of the content register is either in the register or in a main memory. So here we can able to see this instruction. Here the effective address of the operand is the content of what a register and the main memory. So the main memory and register will collaboratively gives this indirect addressing. So here we can't able to directly say where the operands has been going to get located or where the operand are going to be get effectively utilized over these things. So first thing we need to execute this load instruction. Then normally here from this example we can able to say that the processor use the value what the value b in the which is in the register of R5, so as the effective address of the operands. So from this instruction we can able to say thus the R5 is the effective register, which means that the effective address of the operand can be directly fetched from this what the b operand. So then it requires the read operation in order to fetch the content in the location of b with respect to that of in that memory. So after that the value from the memory, which means that the main memory is the desired operand. So where we can able to, which means that the loaded content, which will load the content into the register of R2. So this is the indirect addressing mode. So the next addressing mode is the index addressing mode. So from this in the index addressing mode, the effective address. So in this previous addressing modes such as immediate addressing mode and register addressing mode, direct and indirect addressing mode, the things is which means that the effective address can be either it has been explicitly mentioned in the register or in the main memory. But here this in the effective address is able to get generated with the help of what? By adding a constant value, which means that this constant value will helps to tell the effective address of the what addressing mode. So from this instruction move r1 comma r2 plus 4, here this 4 tells us that which from this instruction we can able to say which type of processor has been used. So from this we can able to say that a 32-bit processor has been used, which means 32 bits. So 1 bytes, so 1 second it carries us of 16, so 8 16 and 24 and 32. So the 4 bytes has been get involved. So in that 4 bytes we can't allocate the next thing, which means that in order to store that memory, so automatically we can able to say that it is a 64-bit processor. So things is that gives us of what 8 bits is of carrying things. So from this instruction we can able to say that it is saying that the register r2 will move the content, which means that the r2 content after to the top fourth element, which means that accessing the element from the fifth box. So it is a 64-bit processor, so accessing the fifth box of the register, that r2 register will again then move to the top r1. So this is the index addressing mode. Next is the auto increment mode. So from that auto increment mode we can able to say that it is going to be get increment of value of 1. So how that value of 1 get means they get incremented, so incremented by 1 is common in this both instruction. So where the increment 1 has been done, it is the major issue here. So from the instruction move r2 comma plus r naught, so here this instruction says that move r2 comma r1, after that it has been plus. So first the thing going to be do in this auto increment mode is it will copy the content from a register, which means that lastly placed, which means the source and destination. The source register contents has been first initially get copy, and it where, which means that from this instruction the copy it get copy the content of the register r naught, and it into where it will send to the memory location whose address has been specifically has the content of the register r2. So after that copying, after doing this copying operation, the content of the register will automatically get incremented by 1. So here when we put plus a nearer, which means that after to that of source register, the it says is that after copying the operations, which means that after copying the r naught content to r2, the r2 register only going to get increment by 1. So while here in the below instruction the plus symbol has been mentioned before to that of source register, so here the incrementation will done only in that of source register position. So r1 is going to be get incremented by 1. So this is auto increment mode. The next is the auto decrement mode. So here this auto decrement mode will be do the process as similar to that of auto increment mode, which means that copying the content first initially done. So after that the decrementation has been done in the where. So here we can able to see this, the content of the register r1 is decremented first. So first thing we are going to do is the decrementation process. After the decrementation process we are going to do the same process done in the incrementation. So the here in the decrementation the first thing is firstly we are going to decrement the r1 register, which means that here the content of the register r1 is going to be get decremented. The content is the thing which is going to be decremented over here. Firstly we are going to decrement that only. After that we are going to accessing the same instruction points as has been mentioned over there. So the next addressing mode is a relative addressing mode. So here this relative addressing mode has been expressed with the help of determining the program counter and with respect to the offset value. So here we having what an instruction. So here the program counter is mentioned. Followingly it says is that of plus 200. So here this plus 200 says is the offset value, which means that the offset says is that the positive or negative integer mentioned. So here this positive things has been will helps us to give the effective address. So the effective address is determined with the help of what are the things, the program counter and offset. Here in this instruction the offset is plus 200. So here this it has been used as a branch, or it helps us in the doing that of jumping operations. So with respect to that of jump 200, so we are going to use this instruction jump to PC plus 200. So automatically the program counter will increment it to the top plus 200 and do the jumping process. This is the relative addressing mode. So the next addressing mode is implied addressing mode, which is the last addressing mode in this addressing mode topic. This implied addressing mode will implicitly, before that we are explicitly defined where the effective address is going to get placed, either in the register or in the top main memory. But here this operand is implicitly defined by the instruction itself, which means that there will be a no need to specify an address or register in the instruction. So following these instructions such as the clear, no operations, increment and return, this says is that we doesn't need any of no operands in order to explicitly get specified. So thank you.